Good evening, friends. Today we'll start with uh, analyzing some very important part of our first MapReduce example. Okay, so in the last class, what we discussed is we discussed how to process a word count example. Is not it? So in that process, we had given a path called input directory and one path called output directory. So while this MapReduce program gets executed, the input will be taken from this path. Is not it? And this is SDFS path. We can go to the SDFS path and you see input data is a folder, a directory. Here we have two files. In the last example, whatever we discussed, there we had placed only one file. Here we have three files. So in this case, here we have two files. So in this case, our MapReduce program will work on both the files, this file as well as this file. Okay, now let me run this program. I think I need to delete this. Say F5, refresh. Once you delete that, say refresh. 1 minute, my cluster is not running. I'll say start all. Done. Now you delete this output directory. Okay, it is in the save mode. So we got a problem here. Let me rectify that. Okay, we'll discuss that later. Okay, don't worry about that now. Alright, so the output directory got deleted. Now in the input data we have two files. One is abc.txt, another one is word.txt. Let's right click and say run. Fine, the program got executed. You just refresh this folder. We got the output data. So in this case, how many result file will be created? This is my question. Earlier in our example we had only one file in the input data, right? So our MapReduce programming started working on that, and finally we got a folder called something called M or R000, if you remember. So now this time, how many folder will you get? How many folder you will get in the output data? Will you get 2 or will you get 1? Okay, so as per our last class explanation, since I have two files and two files are of very small size, so how many blocks will be created for this? 2 blocks. For each file, 1 block, right? So each block will be executed, will be processed by a mapper. Is not it? In the map slots. After that, the output of the map slot will go combiningly to the reducer. Right? So the combined output will go to the reducer, and in the reducer the file will be processed again. The output will be processed. So the reducer writes the file into a single file. The reducer writes the data into a single file. That means even if you have 1000 files here, for processing, okay, still the output you will get only in one folder. See this part_r_60. What is the meaning of R here? Yes, what is the meaning of R here? R means reducers, right? That means our reducer also got executed. Okay, if you disable that, you will see M. We will check that later. If you disable the reducer, it is also, you can also disable the reducer. If you disable the reducer, then you will get here M. That means only mapper was executed. Okay, now let me go to this file. See this: orange, orange, apple, ball, cat, dog, egg, orange. Total word count. Okay, so now let's try to understand some peak point about this example. Okay, now I'll start with a simple document. Now this is the first question: how many times the mapper map method will be called? If you look into this program, mapper, this is my mapper. I have a map method. How many times this map method will be called? If I have two files, okay, let me give you an example. If I have two files and each file has got 1000 lines. If I have three files, okay, and each file has got 1000 lines, how many times your mapper method will be called? 3000 times. Yeah, that is 3000 times. That means what will happen is your MapReduce framework if I say that this is your MapReduce framework, okay, if this is your MapReduce framework, then what it will do is for each file, okay, so this is one map slot, this is one map slot, and let's say this is one map slot, 3 map slots. Now each block will be executed in a map slot. Block 1 will be executed here, block 2 will be executed here, block 3 will be executed here. Okay, now this block 1 has got 1000 lines. Okay, this block 2 has got 1000 lines, this block 3 has got 1000 lines. So the map method will be called for each line. Is not it? Now the question is, this map method is a static method or non-static method? This map method is a static method or non-static method? This map method is a static or non-static? Non-static method, right? We have not written static keyword here. Okay, so non-static method, to call a non-static method, you need an object or not? Yes. So who needs the object? The MapReduce framework needs the object of our mapper class, right? The MapReduce framework needs the object of our mapper class. So what will happen is, this task instance, okay, what they will do, they will create the object of our mapper, my mapper equal to new my mapper. So once object is created, map dot, or let me just write mapper dot map method, and in the map method there are 3 arguments, right? There are 3 arguments in the map method. One is input, key, input value, and what is the third output? What is the third input here? Third argument? Context object. is not it? Key, value, context object. Okay, so in each box, in each task instance, they create the object of mapper. Okay, so in this transition, if I have 3 files, how many object will be created of mapper class? Yes, how many objects will be created? Mapper class, 1 for each, total 3. Okay, 1 for each, total 3. So you just go to this program and let's try to run this example. Okay, now my input data is here. I have 2 files here. Okay, I have 2 files. Let me delete this. I'll delete this one. Say okay, deleted. Now you go to the driver class. I will do one thing. I will not execute this program. I will execute this program. Let me say Ctrl+Shift+W. Okay, my driver. This program is also same. Only what I have added is I have added this SOPs. Right click and say run as Java application. Okay, go to top. You see here one constructor got called. That means object is created or not. Similarly, just go down somewhere, you will see another object, this one. One more constructor got called. That means 2 times object got created. Getting my point? 2 times object got created, because in my case I have 2 input files. So each input file will be considered as a block, and each block will be executed by one task instance. Am I clear on this? Now let me take one example. Let's say I have 3 files. Okay, I have 3 files. File name is word1.txt, word2.txt, word3.txt. Okay, the size of this file is 100 MB. The size of this file is 200 MB. The size of this file is 5 KB. Okay, so totally how many blocks? For the first one we need 2. For the second one we need 3. I'll say calculator, 200 by 64. 4 we need. So 4 plus 2 6 plus 1 7. Okay, so for this file we need block 1, we need block 2. 2 blocks we need. For this we need block 1, block 2, block 3, block 4, is not it? And finally block 1. Okay, so if I have 3 files, then totally it will be divided into 7 blocks. So 7 block means how many times the mapper object will be created? 7 mapper object will be created, and internally map method will be called individually. Is not it? Internally map method will be called individually. Let's say you have a cluster of 10 nodes. That means 10 different computers are grouped together in a network, and we are using it as a Hadoop cluster. So your 10 files, your 7 blocks may be processed parallelly by 7 nodes parallelly, is not it? In the best case. Okay, so we understood how many times map.map method will be called. Now the question is, how many context object will be created? Here we had context object. Similarly, here also you'll have context object. Here also you'll have context object. So the context object will be set or the context object will be created. Getting my question? My question is, in this mapper, we agreed that mapper object will be created for each run, and then map method will be called, right? For each line, map method will be called. In that process, how many context object will be created? 1 or 2 as per our example, or 7? Okay, I'll take this example. Let me take this example. Okay, I'll not take that example. Let me take this example. 3 files with 7 blocks. How many context object will be created? A single, and it will be said, or multiple? Multiple, yes. 7 will be created as per this example. Okay, 7 will be created as per this example, and as per our practical, we have 2 files. 2 files means 2 blocks, and 2 blocks means 2 different context object will be created. Can you prove that? Yes. In the map method, see this, this my first mapper number 1. Okay, first time. Now here, if you see, the context has code is 205391 at the end. This one for first line, second line, third line, fourth line, fifth line. Next, again go down, mapper object got created. This time you see the hash code, it is 631. This is 391. That means there are some difference in the hash code. Do you know what is hash code in Java? It is not exactly the memory location, but it is a way to tell that the two objects are not same. Is not it? Basically, you can follow this blind rule that if two hash codes are different, then the objects are not same. Okay, so here you can see, that the hash codes are different. That means they are really different objects, so context object will be different. Now let me tell you how does the MapReduce work. You wrote a program, okay, the map method is getting executed. Map1, let's say I have a map slot, okay, running on a file of 1000 lines or 100 lines. So how many times map method will be executed? I have a file 1, okay, for file 1, one map slot, I'll say block 1. For block 1, I have a map slot, it is executing 100 lines. How many times the map method will be called? Map method will be called 100 times. Now each time we write context.write, is not it? Each time we write something like context.write key and value pair. Okay, so all this will be stored in one context object. Okay, again next time you may deal with block 2. For block 2, again let's say map slot is executing 100 lines. So here also you'll write context.write. So these two context objects are same or different? Block 1, block 2. We have two blocks. So two different mappers object. and the context object will be same or different? Different, of course different. Now as a programmer, we will keep on writing the data in the context object. Okay, we'll keep on writing the data on context object, different context object. Now the framework will do what? The framework will take all the key value pair from all the context object and it will push it to the further phases. What is the next phase after map? What is the next phase after map? In between map and reduce there are some phases, right? Shuffle phase, yes, shuffle. So shuffle phase, right? So in case of shuffle phase, the MapReduce framework will start reading the data from all the context objects, okay, and it will put it on the shuffle phase, and it will be shuffled together, and then it will be grouped, right? Getting my point? Okay, the next one is, we have seen that while executing our MapReduce program, in the driver class, we have specified our input path always as SDFS path. Is not it? Input path SDFS and output path SDFS. That is what we had done in the last class. Now the question is, can I point it to local file system? I want to read the data from local file system. Is it allowed or not? We will check, but what do you say? Is it allowed or not? Can I read the data from can I read the file from local path instead of SDFS? We will see that. Okay, practically it is allowed but not recommended. Okay, practically it is allowed but not recommended. So we will see that. What we will do is, let me do it like this. I'll say Control Shift T. Okay, now let me go to my I'm in my home folder. I'll say mkdir input path or input data. I created a folder called input data, cd input data. I'm inside that. ls, no files are present. I'll say vim word1.txt. okay, so I'll say apple insert mode, apple orange ball, apple ball, orange escape :wq. Alright, vim word2.txt. okay, here I'll write let's say laptop camera 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 WQ. Alright, so I have created a folder as a present working directory. I have created a folder called input data, which contains two files, word1.txt, word2.txt. I want to process this file. Okay, earlier what we had done, we had loaded it into SDFS, and in our MapReduce program we configured that input path, right? But this time I want to configure this path. Copy, paste. Okay, now output path, Also let's do like this: sdfs colon slash slash localhost colon 5432 54310. Okay, so as per this example, what is my input path, local or sdfs? As per this example, what is my input path, local or sdfs? Local. And what is my output path, local or sdfs? Correct. So let me go to this area, output data. Is there any folder called output data? F5. Okay, no folder. Right click and say run as Java application. Executed. Let's see the output. Output data. Okay, do you see camera and laptops? That means you can still process the data which is present in your local file system. Clear? However, it is not recommended. Why? I will tell you a very solid reason for that. But for the time being, just try to understand that yes, it is possible to process the data which is present in your local file system. Okay, similarly, let's now point to a local file system. I want to write that data in a local file system, /home /hd user. Okay, output data 1. I want to read the data from local file system. I want to store the output into local file system. Okay, right click and say run as. Program got executed. Let's open terminal. We are in the SD user only, present working directory. Say ls. You have a folder called output underscore data 1. Say cd output data 1. Say ls now. Okay, we had success dot underscore success and we have this part. Check this output. More part. We got the output here. Okay, now again let me run this program. Run as Java application. Okay, 1 minute. Run as Java application. You see, we got an error here. File already exists exception. Can you tell me why is this error coming? Can you tell me why this error is coming? File already exists exception. This is because of output file. Yes, the output folder exists. Right? Now the question is, why Hadoop does not allow us to override by default? Are you getting my question? The question is, why Hadoop is not allowing us to by default, override the data if already exists? The reason is very simple. Assume that you have written a MapReduce program and you have a file of let's say 200 GB. Okay, you had a file of 200 GB, you wrote some MapReduce program, and the output you process by taking 4 hours, 5 hours. After 5 hours you got the output in this directory. Okay, after 5 hours you got the data in this directory, and now somebody else came again and he wrote one MapReduce program, and he mentioned the same path. And if the override, if Hadoop would have allowed that override facility, then what would happen? Your 5 hours of work would be wasted, is not it? So that is the reason Hadoop will not allow you to override, okay, by default. But if you want to do that, there is a small way to do this. What you do, you create the object of file system. File system fs equal to output directory dot get file system. Create the object of file system, and once created you say fs dot delete. Okay, the meaning of this true means delete the data recursively. If any folders and subfolders are present, still you delete the data. Yeah, it is just to prevent data from being deleted. Otherwise, if somebody might have executed a MapReduce program which which would have taken 300 GB of input data, and it took let's say 4 hours, and somebody else comes up with a simple MapReduce program, and if he by mistakenly mentions the same path, then your data will be lost. Okay, so this is also done. Now the next one. Okay, so what I will do is, now just check it out. I'll show you one magic today. So this path is pointing to local or SDFS. Local. This path is present in local or SDFS? Local. That means input path is in local and output path is also in local. So on the safe side, let me delete this directory also. I'll delete this folder, cd dot dot, I'll say rm -r output star ls. Okay, so the folder got deleted. I'll say data1, I'll say just data. Okay, now let me open a terminal and I'll close the cluster now. Stop all.sh. Stopping the task tracker, stopping the name node. Okay, done. Now I'll close this. Okay, I'll say F5. Not able to access SDFS. Now I want to I will execute this program. What will happen? We have stopped our cluster. The cluster is not running now. Hadoop daemons are all down. It is not running. And I just want to execute this driver class. So if I execute this driver program, what will happen? Will it be successful or will it throw some exception? Let's check it out. Right click on this and say run as Java application. Okay, it executed, but now the question is how come it got executed? My Hadoop daemons are down, right? My Hadoop daemons are down. That means no name node is running, no job tracker is running, no task tracker is running. So who processed that? I understand that the files are in local, it should run. I agree with that. But ultimately, as we had discussed that in case of MapReduce, there are some component like name node, data node, right? And task tracker, job trackers. Now, those are all down. Are you getting my question? Now the answer is by default when you run your MapReduce program, it runs on local mode. Do you remember we had discussed the modes in Hadoop? How many modes we have in Hadoop? Okay, what are those? One is local mode, one is pseudo distributed mode, and another one is fully distributed mode, right? So by default when you run this MapReduce program, okay, it runs on a local mode, okay, and in local mode there are some components, there are something called local job runners. Okay, so this actually runs your program. Getting my point? So this actually runs your program, due to which you are able to run your MapReduce program. Okay, so as long as you have a path pointed to local file system, you don't need to have your cluster running. It will do the job. Are you clear on this? So till now whatever example we have executed that program only in local mode. We have not executed that program in pseudo distributed mode, in distributed mode. Okay, now next is how to delete the output folder programmatically. We have already discussed that, right? Get access to the file system somehow, and then you say file system dot delete output directory comma true. Okay, so this will delete your output folder. If you write here input, it will delete the input folder. Do you remember in the very first example we discussed how to programmatically work with SDFS? Is not it? Our first program, programming SDFS. So it can be useful in these places. Okay, now the next point is why do we need this output key, map output value class? Why do we need this? This was the question from someone in the previous class, is not it? So as we know that in MapReduce programming, everything is in form of key value pair, right? So if I take the example of word1.txt, it hardly contains lines. Apple, orange, apple, 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 orange. So in our MapReduce program, let's say we have a word1.txt file as an input file, and it hardly contains 2 pieces of code. Now to give this data to, before giving this data to mapper, okay, it will be converted into key value pair, is not it? So what is the default key value pair? Do you remember? Input to mapper. What is the default key value pair? I mean input key value pair. What is that? Yeah, int writable, but actually it is long writable. Okay, actually it is long writable and text. Okay, long writable and text. You can even put int writable, that is okay, but actually it is long writable text. Okay, now who does this conversion? This conversion is done by input formatter. Okay, converting the raw data into key value pair is done by input formatter. Okay, and in case of our plain files, the default key formatter, the default input formatter is text input formatter. Okay, what I mean to say is, whenever you give abc dot, or whenever you give word1.txt file, it first goes to text input formatter, which reads the line one by one. It will read each and every line one by one, and it then converts it to long writable and text by default. Okay, then this output goes to your mapper. Okay, mapper output comes finally to reducer. Reducer output will be written to a file, is not it? But not directly. It takes the support of output file format. Okay, so this is the guy who converts the data into key value pair, and this is the guy who writes the data into a file. Alright, so by default, text input format, by default, this text input format writes the data to the mapper as long writable and text. Okay, and the output formatter, this output formatter by default writes the data to the file in form of I'll write it here, text input formatter, text input formatter. Long writable text, and here it is text int table. Okay, so if you violate any rule, like, you can still change it. If you need to change, if you want to change, then you have to explicitly mention it here. Okay, and here if you see map output, that means I am just trying to tell that map output should be of text type, map value should be of int type. See, you'll get the data into the mapper. Mapper will emit data in key and value pair, right? So the output of the map will go in this format. The output of the map value, map key, map value. Okay, the output of map key will be of text format, the output of map value will be of int table. So this is the only reason we are giving this information. We are just trying to tell the framework that while processing we need the data in this format, we will get the data in this format. Clear on this?